Hello friends, today's question. Consider regular polygons with a number of side n, 3, 4, 5 and so on as shown in figure. The center of mass of all the polygon is a height h from the ground. They roll on a horizontal surface about the leading vertex without slipping and sliding as depicted. The maximum increase in the height of the locus of center of mass for each polygon is, it should be delta, not d, depends on n and h as. So these are the four options and we are supposed to find out the relationship between delta, n and h. So in this case it is here they are given three figures. So the triangle which has number of sides is 3, square number of sides is 4, then it is pentagon number of sides is 5. And it said that all these objects, polygons, have the center of mass at a height h and they topple with the leading edge. So this is the leading edge. Okay. So let me draw this figure one by one again. Or we can say let this point be called as a hinge or fixed, okay, because based on this it is going to rotate. So these points are fixed. This one, all these three. Now it is said that the center of mass is at a height h. So in case of the triangle, so this is our triangle and it topples around this point and this height is given as h. If we join this line, then this triangle is going to rotate about something like this, or we can say it will be rotating along this radius, the circle formed by the line which will be acting this line. Suppose this is O and this point is A. Now OA will be acting as a radius for this center of mass. Okay. So at maximum height, let us suppose this is A prime. Now the topple will be coming something like this. Okay, it will be like this. So this happens in case of triangle. Same will be happening for the square also. So this is our square. This is the center of mass. Let us suppose this point is O and this we call as B. And if we join this OB, now this square is going to move or topple along this vertex, that is which is fixed, something like this, which is given in the figure. And this will be forming the radius. So the maximum height, once again, suppose this will become point is B. So this will be our maximum height of the center of mass as it is going to rotate. Same thing is going to happen with this pentagon also. So we can draw this pentagon also. So this is height h and this is point O, and if we join let us call this a point C. So it will be going to center of mass is going to form a circle in this way, and let us suppose by default this is our B prime and this is C prime, which is the height of this center of mass as the pentagon is going to move. So you can say, let us divide it into three parts. In the first part, you can say that the center of mass from point O, which is fixed, is given as OA. Center of mass is at a distance OA in this case. Center of mass is at a distance OB, OA from fixed point O. Here also center of mass is at a distance OB from fixed point O. And here also center of mass is at a distance OC from a fixed point O. Okay. And the second, you can say in all the cases it will rotate about OA. Similarly here also it will rotate about OB, and it will rotate about OC. So let us redraw only the rotation part. So in case of triangle, you can say that this is point O, this is point A, and let us join it like this. A is our center of mass, so this is at a height h, so this will be our h, and it will be rotating in this direction, and we said that this is our A prime. So if we draw a line which is parallel, so this will be our delta, which we are supposed to find out. Okay. And similarly, we can draw it for this square also. This is our point O, this is point B, and this height is given as h. So this will be rotating this way, and this will be this is our P prime. So if we draw a line parallel horizontally, so let us call this as, this will be giving us delta. Similarly, we can draw for the pentagon also. For the pentagon also, we are going to get point O, this will be C, height of the center of mass is given as h. It will be following this circular path, and this will be our C prime, and we get the height with which the center of mass is increased is given as delta, which we are supposed to find out. Now we can say, as a circle is formed, so let us say that OA is R, that is radius of the circle. Okay, we can say that OA prime is the maximum height of center of mass In this case, OB prime is the maximum height of center of mass, and in this case, final case, in case of pentagon, OC prime is also maximum height of center of mass. So as it will be a full circle. So if under this condition, the OA prime will be equal to OA. OA prime will be equal to OA. OB prime will be equal to OB, because all this OA as well as O prime are nothing but the radius of the circle. Okay. And OC is equal to OC prime. And we said that let OA is equal to R, so this will be equal to R. This is also equal to R, we call this as R. And finally this also, OC is also R, so we get R. Now the increased in height is delta. So we get, let us call this point as A double prime. OA double prime is H and OA prime is R. So delta means A prime double A prime is equal to R minus H. Similarly, let us call this as B double prime. So we can say delta, which is equal to B prime double prime, will be equal to, once again, OB double prime is our R. Sorry, not R but H. So here also we get R minus H. And in the last case also, let us call this as C double prime. So delta is equal to C prime double prime. We get this will be equal to R minus H. So in every case, delta, that is the increase in the maximum increase in this center of mass, is equal to R minus H, R minus H and R minus H. From here we can say the maximum increase in the height of center of mass is equal to R minus H for all figures. Or in the shorter form we can say delta is equal to R minus H. Now let us find out, because here the angle is also given in the form of the radian. So for the triangle, we have center of mass whose height is given as H, and this angle is given is our theta. Therefore, and the complete angle, this angle is 360 degree. So we can say theta is equal to total angle divided by 2 multiplied by 3. Similarly, for square, we have this height is H and this is theta. So here we can say theta is equal to 360 divided by 2 multiplied by 4. 4 are the number of side. And similarly for this pentagon also, angle theta, this height is H, so we can say theta is equal to 360 divided by 2 multiplied by 5. So 3 is number of side, 4 is also number of side, 5 is also number of side. Therefore we can generalize this formula as theta is equal to 360 divided by 2 multiplied by n, where n is equal to number of sides. Okay, so we can this just you can say convert this into radians. You can say theta is equal to two pi by 2n, or we can say theta is equal to pi by n radians. Now we are simply you going to use a right angle triangle like this in every case. This is point O, and this is point for every case it is B, A, B or C. Okay, and this is our height h, and we are given this will be our, we have taken this as radius r. Therefore we can say, and angle is given as theta. So for the triangle we can write that r is equal to h cos of theta. Theta we already know, so we can write h cos of pi by n. We already know the relationship between delta r and h. Let us call this as equation number 1. So we can say, using equation 1, delta r minus h is equal to h cos of pi by n minus h, taking h as common, we get delta is equal to h 1 upon cos of pi by n minus 1. So this is the maximum increase in the height, giving the relationship between h and n. And for the option, you can say D is the correct option. Option D is correct. So this completes the question. Thank you.